Okay, so I went and did all of my calculator stuff on another video. So I went and put Alan's numbers in L1, Brianna's in L2. Then I ran a one vars on both of them separately. So I had to go and do calculator and I had to do list one for Alan. And I got all my information here. Mean is 90, standard deviation, median, min, max, quartile 1, quartile 3. Did the same thing with Brianna. Okay, so now we can compare their data. So let's see what the first question said. It says, which student had the higher mean? Well, it looks like both of them had 90, right? So I would have to say they're just both 90%. Same, 90%. So there's not much comparison there. Okay, so which student had the higher median? Well, again, they're the same at 90%. So does everybody see how we're comparing them? They're both 90 right here. And then they both have a mean of 90 also. It says, what might be the problem with using these measures of central tendency? Okay, well, using the mean and the median, they're both the same. So they look the same, don't they? They look the same. But they're not. They're not the same data. If we look a little closer, go a little deeper, they don't look the same. So now let's go check our other forms of variation. Remember, we were going to look at your range. So this is where we get into the variation. So we're going from the mean and the median that we talked about yesterday, that we're talking now, we're digging a little deeper into the data and we're going a little further. Now we're investigating more the variation. What is the difference in the data here? So let's first start off with range. Let's do range. Okay, so if we were to look at this, I can see if I do that, I can see both of my screens at the same time. So I'm hoping that's okay with you guys. Alan, and let's look at Brianna. So if I did Alan, his max was 100 minus his min is 80. So that gives me a range of 20. Okay, and let's look at Brianna. So Brianna's max is 91 and her minimum is 89. So that gives us a difference of 2. So if we're looking at the range, what data would you choose? Would you choose the higher range or the lower range? Well, higher range means you have more variation, you have more differentiation, where if you have a smaller range, you then do not. All right, let's go look at what is the IQR of each data. Okay, so remember IQR, you're measuring your Q3, which for Alan is 89.5, minus your Q1, which is an 81.5. So hopefully this is correct. My numbers are correct. I don't have a calculator with me, but that's 17. Whereas Brianna, her Q3 is 90.5 minus 89.5. So that's a difference of 1. Again, here we go. Brianna has a smaller variance here. So let's look at number 6. It says, using the measure of variability or measure of spread as a possible determining factor for a Scholage recipient. So let's look at this and let's look at the standard deviation on this one. So okay, so standard deviation. Let's look at Alan first. So Alan's standard deviation was 7.8. If we go look up here. So 7.8, whereas Brianna is a 0.707. So which one is smaller? Because remember, the smaller the standard deviation, the more clustered around your mean is. Well, because our mean and median is the same, they're at 90, wouldn't you want those data values to be, if they were going to be more consistent, you would want this smaller standard deviation. And in the real world, when we're talking about and analyzing data, typically people want their data clustered around the center. It gives them a more accurate depiction of how that data performs, or in our case, how that student performs. So here it says, what does the difference in the measures of variability or the spread suggest? Well, this suggests that because Brianna has a smaller standard deviation, she is going to be more consistent. So here is Brianna is more consistent. Okay, so Brianna is more consistent. Now, it says, explain which student you think the teacher would choose and why. Well, we kind of just talked about this. We would choose Brianna. Well, most teachers would choose Brianna because her standard deviation is lower therefore she is more consistent to the mean average. Okay. I hope that makes sense. Smaller standard deviation means more consistent. Did not spell consistent, right? There we go. Consistent to the mean. Okay, so we'll flip over. Okay, let's talk about an outlier real quick. Because remember, we talked about outliers can throw your mean off. Remember, it can shift. If you have a big outlier, it can shift your mean higher than it really should be. And if you have a very low outlier, it can shift your mean lower than it really should be. So an outlier is an extreme value that's much less or much greater than the other data values. Outliers have a strong effect on the mean and the standard deviation. So if an outlier is the result of measurement error or represents a data from the wrong population, it is usually removed. So what that's saying is, in the real world, if you have this random, if you're a researcher and you're collecting research, let's say on some new vitamin or drug out there to cure cancer. So if you're taking all these samples of data and then you have this one that is like, how is this possible that we're getting this data value? It could be from error on some part. Somebody messed something up or whatever. So typically that's saying that they throw that out and kind of ignore it and stick with what's more consistent. And that's only if it happens like one time. If there's a lot of outliers, then obviously they have to take those into effect. All right. So in here, we're not really going to throw away any outliers. So there are different ways to determine whether the value is an outlier. Okay, so one is to look for the data value that are more than 3 standard deviations from the mean. So we'll talk about that. So when you're looking at a mean and you're looking at to see if it's 3 standard deviations away from the mean. So that means if you had a mean, let's say, of 2, for simplicity's sake, we're going to make this easy. And our standard deviation, let's say, was 1. So if we had to, we would go, how many standard deviations? Well, this would be 1 standard deviation. So that means we would add 2 plus 1, and that would give us 3. And then our next one, we would add another standard deviation to 3. So that would be 4, another one to, and we would get 5. So this is 1 standard deviation, 2 standard deviations, 3 standard deviations away from the mean. And you would do that on the opposite side. You would just go backwards. You'd go minus 1 standard deviation. So that would be 1 minus 2 standard deviations away from the mean would give us 0. And minus 3 standard deviations away from the mean would be a negative 1. So what they're saying is we consider they're an outlier if you were to take a data value set and it's anywhere outside of these 7 numbers, okay? So 7 numbers. We would throw them out, essentially. So let's see of an example and see if this makes a little bit more sense to you. All right, so in 2003-2004, the American League Championship Series, the New York Yankees scored the following numbers of runs against the Boston Red Sox. And here's the data. So you need to, right now, plug this into your calculator. You need to plug it into your calculator, and you need to run a what? 1 bars. So plug it in, enter the data values in list 1 on your graphing calculator, and then go find your mean and your standard deviation. So if y'all want to pause this video to go do that real quick, because I don't have my calculator is not working on this recording. Okay, so when I did this, I got my mean was 5.4 and the standard deviation was 4.3. I'm hoping you guys did that and got that. If not, help each other out. All right, so here's how we identify the outliers. Okay, so we look for the data values that are more than 3 standard deviations away from the mean in either direction, okay? So what we can do, instead of adding, like we did up here where we added a standard deviation 3 times, well, what you could do is you could say, well, let's just do 3 times our standard deviation. So if our standard deviation is 4.3, let's multiply our standard deviation times 3, and let's see what we get. So when you do that, I think you get 12.9, right? So 3 times 4.3, we get 12.9. So that means if our mean is at 5.4, then if we add 12.9, we're going to be 3 standard deviations away from the mean. That puts us at 18.3 right here. Do you see that? So that's, to get that number right there, we did our mean plus 2.9. So that's your mean plus your 3 standard deviations gives you that 18.3. So what if you had to do it on the other side? Well, you would have to, this time, instead of adding your 3 standard deviations, you would subtract it. So you would say your mean minus your 3 standard deviation. And that gives us that 7.5 right there. Okay, so this gives us those numbers. So on this one, we're subtracting the 12.9. So if we get any data outside of this, they are considered outliers, right? So are there any numbers in our data sets that are either negative 7.5. Well, I don't think that's possible. There's no score like that. But is there anything that's out of the 18.3, the high end on our data set? Well, I see a 19. That's above our data set. 19 falls right about somewhere here, right? This is like 19 over here. So any of these will be considered outliers. On this side too would be considered outliers. Okay, so the question says, is there an outlier? And if so, how does that affect the data? How does that affect the data spread? Okay, so yes, there is an outlier. It is 19. And how does it affect the data? Well, it's going to skew, and we'll talk about this a lot more later. It's going to shift. Let's use that word for now because skewed might be confusing right now. So it's going to shift the mean higher. Okay, and how does this affect the spread of the data? That means it's also, if it's going to affect the mean, it's also going to affect the standard deviation. So that means it also shifts the standard deviation, we're going to abbreviate here, higher. Okay, so now it says remove. So let's test it and see if it actually does. Let's see if it actually does what we think it should. Does it make the mean higher? Does it make it lower? Does it shift the standard deviation? So this time, go back to your L1. Go back to your L1 and remove 19. Go back and remove it. Okay, so if that means you have to type it all in again and just not put 19, then so be it. Go do it. So let's figure out what our data looks like without the outlier. Go do it. Pause if you need to. Okay, so when I did this before and I ran a 1-vars after I threw the outlier out, I got my mean is 4.3 and my standard deviation is 2.2. So let's see what it actually did here. Well, it definitely, without the outlier, it did decrease our mean, right? So the outlier did what we thought it was going to do. It increased it. So the mean increased from 4.3 without to 5.4 with the outlier. And the standard deviation was also affected. It went from 2.2 without to, what was it originally? Let's see, what was it originally? 4.3. Okay, so what does that mean about the spread? Okay, I'm about to write a lot, so here we go. It says the outlier affects the mean and the standard deviation. Okay, so we know that. So if you get rid of the outlier, the mean will decrease. As well as the standard deviation. Okay, so the outlier affects the mean and the standard deviations. So if you get rid of it, if you get rid of the outlier, then the mean decreases as well as the standard deviation. So, okay, so that's all for me today. Oh, well, look at there. Let's respell this the correct way. So on the other page, you have homework. So if you will go ahead and use the remaining class period to work on your homework. You have 1, 2, 3, 4, 5 problems. So make sure you read the directions. I want you guys to work on not only finding the standard deviation, the range. I also want, when you get down here to the cell phone company one, compare these data sets and figure out which one would be better, especially when you're comparing the mean and the standard deviation. Okay, have a good day.